My name is Vishwanath. I'm an urban and regional planner and a civil engineer by qualification. I've been working in the sector for close to about 30 years now, looking essentially at decentralized water management and wastewater management systems, including rainwater harvesting and ecological sanitation systems. I was working with the government of India with a group called HUDCO for about 15 years, and the next 15 years have been on my own. The state of sanitation is pretty complex, urban India. Very few towns have underground sewage systems. Numbers are available, but it runs in the hundreds instead of the thousands. If of those who have underground sewage systems, even less have sewage treatment plants. And the collection of the sewage treatment plant of wastewater is inefficient. Further, the treatment of it is even more inefficient. So things are pretty much on the go. Wastewater systems have to come in the future. But I think urban India essentially, to a large extent, depends on on-plot sanitation systems. Luckily, the on-plot sanitation systems were for the first time mapped out by the Census of India 2011. Before that, we didn't even have an idea of the numbers. And though these were sort of told by people themselves, they give a broad picture of what on-plot sanitation looks like. And this is typical Bangalore. You'll get the background. But the numbers are fascinating, and they run in millions, actually. Now, advantages and disadvantages. The advantages of on-plot sanitation system is they require less water. Typically, underground storage systems require a minimum self-cleansing velocity of flow, so they require 135 liters per capita per day. But on-plot sanitation systems can do with as less as 70 liters per capita per day. The disadvantages of on-plot sanitation system is that it led to the practice of manual scavenging, even though it was waterborne in many cases. Many cases there were sometimes dry latrines too, and that's been a major problem. The disposal of the collected waste in the pits have also been a problem. In the current days, luckily, mechanization is creeping in, and somehow the systems are getting better. But still, we do not have adequately understood how these collection from the pits, the removal of the waste and the dumping of it or the placing of it, how does it happen? That's not clearly understood. So that's a problem. Typically, the most common one which I've seen is the single pit toilet. So you just dig a deep pit, sometimes line it with stones, sometimes it's unlined, depending on the soil profile, and you barrel in all the water into it. Sometimes only toilet waste is led into this pit, sometimes grey water too is led into these pits. That's very common. The second more common ones, though in percentage terms it would be about 5% or less, is the septic tank. Now, the conventional ideal septic tank would have 3 chambers at least, would have place for sludge to be removed and scum to be removed, and then the liquid effluent would go into a dispersion trench or a leach field. That is not happening. What's happening is that there's a big box chamber, water and wastewater is barreled in one side, and then it flows out the other side. Sometimes to stormwater drains, sometimes on the land, sometimes in natural gullies and nalas. These are the 2 most common ones. Slowly, in some places, twin leach pits are coming in, and even more slowly, eco-sand toilets are coming in. Now, conventionally, the National Building Code and the Bureau of Indian Standards have only insisted on septic tanks as a civil engineering response or a sanitation response to waste management in toilets. Now, the septic tank design is not followed in practice because most houses are not built in the formal sector. They do not need approval. So you have the problems of badly designed septic tanks. The pit toilet, unfortunately, is not there in the code of practice at all. So this is completely in the informal sector, and people are building their own pit toilets on their own without taking care of what it does in terms of groundwater pollution or what it does in terms of soil pollution or even surface flow pollution. So unfortunately, the formal design sector has not really understood what is happening on the ground and not provided solutions which are practical and doable on the ground. So that's been a construct problem. So again, there are two ways of looking at it. People are doing very deep pit toilets, and that's been the practice even in South India. Katihar is in Bihar, but everywhere across, where they can afford, they make a very deep pit. Why is that? Because they don't want to get into the headache of emptying it. Emptying it gets into manual scavenging. It's really tedious and complex a process. So people want to design something which lasts 25 years or 30 years. That's why they do the deep pit toilet. There's very little understanding of the groundwater and pit toilet interface. The classic example is Kerala, where you have the single largest density of open wells. People's dependence on open wells is the highest, yet people are still building single pit toilets, piping in sanitation into the same groundwater which they are using for drinking water, and this is a literate state. So if in a literate state where people know generally and are aware, the response has been not to understand the interface between groundwater and sanitation and to build pit toilets and have open wells close by, you can imagine what will happen in other areas. In other areas, the single key driver, as I told you, is the non-emptying or the life of these pit toilets, which they want to be, which should be long. Now, the design response for it need not necessarily be a civil engineering response and push you to septic tanks, because even the septic tanks have been badly studied and they do not perform the way they should perform, and they're in no way significantly better than pit toilets. Perhaps the design intervention is to understand the pit toilet and to suggest improvements which will have positive outcomes, where it will not pollute the groundwater, where it's easy to clean and where it's easy to maintain. Perhaps that's the way to go. For a long time, it was manual scavenging. People would get in, empty it, and the distance to which it was emptied would be determined by the wheelbarrow. So it would not be more than 500 meters at the most. So it would be dumped in the periphery. Now that the Manual Scavenging Act is actually being implemented with more vigor, and human rights commissions and high courts have cracked down on this, mechanization has crept in, and so the honeysucker. And I see the proliferation of the honeysucker and a constant growth. This vacuum sucking machine, the truck which comes and then picks up the sludge. Where do they dump it? Different states, different locales, different places. In Bangalore, what I've seen, or in small town Karnataka and semi-arid Karnataka, I've seen very good practices where the honeysucker actually takes this waste to farmers, and the farmers then compost it, desiccate it, and use it as fertilizer. In other places like in Kerala or in Tamil Nadu, one has seen instances of the honeysucker dumping it into rivers, lakes, or just generally being indiscriminate about it. Then again, there's a question of information and nudging better behavior from honeysuckers. That's not been attempted at all. And what has been done is to paint people heroes or villains and not engage with them, but only imagine regulations. So that's been the problem with the pit toilets. With the septic tanks, more or less the same. The sludge, if at all, is emptied once in 10 years or 12 years. And again, it was through manual scavenging. Now the honeysuckers are creeping in. The ideal twin pit toilet, which was designed in India, mostly for rural India, has unfortunately not been put in place vigorously enough, even in rural India. It has great potential. If you switch from one pit to the other, allow one pit to compost for 1.5 years, and then empty it as compost or manure, it's perhaps the most easiest thing to do. We haven't pushed it enough, both in rural sanitation and definitely not in urban sanitation. Well, the question is how much research has gone into understanding what the sludge actually composes of. What is it that we fear in the sludge? There's an inherent concept that it is pathogen rich. Actually, in the pit toilets, when one examines them, because of their age, it's only the top 6 inches to 1 feet which is actually raw. The rest of it is digested and pre-digested. Now, do we really want to treat the entire 20 feet, 25 feet of pit sludge, or should we find mechanisms of treating just the top layer and knocking off the pathogens? What is it we fear? Now, if there is no direct contact during the emptying of the pit, is there any disease transmission that will be an outcome? If not, then why do we want treatment of it? Again, when we dispose it off on fields, if there is no direct contact or there is no inhalation of pathogens, bacteria, viruses, is there anything to fear? And finally, once it is desiccated or composted, what is it that in the sludge that we fear? Is it helminth eggs? Is it bacteria? Is it virus? What is it that we fear? There's not enough research which has gone in, especially from the Indian context, because the tropical Indian condition is way different from other temperate conditions. If we understand what we fear, then perhaps we will design systems which will overcome those negative outcomes. And one good methodology to adopt is the sanitation safety protocol suggested by the World Health Organization, where you create barriers at each level for things that you do not want as an outcome, whether it be a negative environmental outcome or a negative health outcome. At each step of the sanitation process, if you create these barriers, then perhaps as a community you are safer. Well, for example, if the pit is to be emptied, let us say we insist that it should be mechanically emptied. Let us say that we insist that those who empty it should wear gloves and should wear masks at that point of time. Let us say when it's transported, it should be under sealed conditions, that the honeysucker should ensure that there's no leakage of it. When it is emptied into pits, let's say those pits or trenches should be designed so as not to splash or not to ensure air transmission. Let us say once it's emptied, it should be covered quickly with soil. And let's say there's a time frame that should be designated for it to dry, desiccate, or compost. And finally, when it comes to application, let's say that we create a barrier between the application of the fertilizer and the harvesting of the fruit. You create a distance barrier between the fertilizer and the fruit and the crop, and you create a time barrier between the application of the fertilizer and the harvesting of the fruit. So these are simple, practical steps. It looks like that you can actually manage 98 to 99% of our waste using the SSP by the World Health Organization. There are two ways that one looks at it. One, the typical standard way is to regulate, then to create a regulatory body. But in India, I have never found a regulatory body which has not been predatory or which has not used it for other purposes than for what it is created as for regulating. The other method is to nudge people for better behavior. Can we think of economic nudges or information communication nudges, which will inform people about the nutrient value of what they are emptying into fields or into water bodies, and see whether they can properly put it into farms. Otherwise, can we start to imagine sludge treatment plants, not linked to sewage treatment plants, but more linked to solid waste management plants or composting plants, where this waste can be taken and treated properly, appropriately, and its nutrient value reutilized for the farm and for fields. Well, intermediate systems are coming, which are very interesting, because one of the reasons which is happening a lot in Bangalore is because the Pollution Control Board is insisting that apartments and layouts beyond a certain water consumption norm or a certain area has to mandatorily put in their own sewage treatment plants. It also insists that the treated wastewater be reused within the plant, so what it calls the zero discharge norms. Now you have various fascinating alternatives emerging from the conventional ASP systems, activated sludge processes, to the sequential batch reactors, to the membrane batch reactors, technology-wise. Or in terms of the biological ways of treating it, the DWAT system, the decentralized wastewater treatment systems, or the phytorate systems, which is developed by NEERI, or the soil biotechnology as developed by IIT Mumbai. Now, these are hybrid systems. They take the sewerage lines, but then treat the sludge separately and the wastewater separately, and usually meet Pollution Control Board release norms for disposal of water, which can then be used for gardening, landscaping, and toilet flushing. These seem to have the greatest potential because they marry a combination of low water requirements, but also the reuse and recovery of nutrients and wastewater. Well, the question of scaling up is always fraught with consequences. Now, we have to understand why the conventional is failing. In the conventional sewerage system, we have tremendous complexities in design, tremendous negative outcomes in terms of even laying the sewerage pipes, manholes in busy streets and other places. The negative externality, the negative economic externality of transport disruption of people's lives is tremendous, which is never costed into the system. Then these systems typically go through the lowest cost tendering processes, and quality-wise, they're always suspect. So they leak, pipes leak, manholes leak, everything leaks, goes into the groundwater. After that, whatever is collected at the sewage treatment plant, again, is not monitored because the sewage treatment plant becomes a cost center. So it's only an expenditure for the utility. Finally, we have this inability to even collect the O&M costs of sewerage, let alone the capital costs. So the system is kaput, is broke, the conventional system. Now, when we start to compare decentralized systems, what do we compare it with? Do we compare it with the absolute gold or platinum standards we expect from the decentralized systems, or do we do a relative comparison of this vis-a-vis the conventional system, or this vis-a-vis on-plot systems? When we do a relative comparison, I think we're better off or better informed. The true place that they will find is when water is priced correctly. When the price of water reaches a certain tipping point, in particular in Bangalore, I would say that when the price of water crosses 80 rupees a kiloliter, there is an economic interest in making the wastewater treatment plant work. The non-conventional wastewater treatment plants like the DWATs or the SBT actually do not have too much complexities in their running, which is one deterrent for conventional sewage treatment plants, even the decentralized one. Plus, their O&M costs are very less. This combination of low maintenance, low skill set necessary, and low maintenance cost necessary is likely to be a strong point in their favor. The negative point is the kind of space they occupy. In dense urban areas, these biological systems seem to require 1 to 1.5 square meter per person. This space may not be available, but then solutions are emerging. For example, the vortex, which is now being developed in Auroville, CSR, which actually mimics the whirlpool in nature and oxygenates water, reduces BOD, increases DO. So evolution of design is also happening with the non-conventional wastewater treatment systems, and the price of water will actually tip it in their favor. So the private sector is in two ways they play a role. The formal private sector, which does the design of decentralized wastewater treatment systems and puts it in place. It's not the government which is doing it. All of it is being done by the formal private sector. Then there's the informal private sector, which is the honeysucker operators or the ring makers who make these pit toilets or the farmers who use the sludge. Now, they seem to be proliferating because there's a business model here in pit emptying. And they seem to be running it as entrepreneurship. They're doing that in a vacuum of knowledge. They pick up the local knowledge and local wisdom and work with it. But there is space for formal knowledge to help improve their construction of the truck, for example, or the vacuum sucking, for example, or even the desiccation of the collected sludge, for example. So if these two sectors, the formal knowledge sector and the informal entrepreneurial sector, sort of merge and work on their strengths, that would be the ideal way ahead. For example, in Bangalore city alone, there may be 500 honeysuckers, all operated by the informal sector. Each honeysucker costing about 10 lakhs. So that's 50 crores of investment which is coming from the informal sector. They daily do a trip of between 3 and 5. So you can imagine about 2,000 to 2,500 trips by these and they handle close to about 600,000 on-plot systems and decentralized sewage treatment plants, almost equal to the formal sector, which handles about 700,000 to 750,000 connections. So they compete with the Bangalore Water Supply Sewerage Board, and this is Bangalore city. And in the rest of the small and medium town Karnataka, in most places, they are the only alternative. In most small towns, they provide the only sanitation service. This is a personal subjective opinion. Given the fact that the formal sector itself has not shown good behavior, whether in waste collection, wastewater collection, treatment, or sludge disposal, or whatever, one suspects their capability and capacity to do it. On the other hand, one is always afraid that the informal sector may cause negative health outcomes, negative environmental outcomes. So how do we merge these two? That's the challenge. So I think light economic nudges is the way to go out rather than formal strong regulation. Yes, so that is the problem. In the sense, the whole sanitation value chain in the system has to be understood completely. Unfortunately, right from the building construction level, there is no formal requirement for the disposal of waste or wastewater. Now, their formal sector regulation can help. Let's say, the introduction of the twin leach pit could help as a formal accepted design for toilet waste. But then once it comes to the collection and conveyance and the reuse of the fertilizer, then I think we'll have to look at the nature of regulation. This seems to fall more within the purview of the Competitions Commission of India than a water or wastewater utility. So when we reimagine sanitation as a market, we have to reimagine the institutions which will govern that sanitation space. I don't think we are doing in the conventional sense. We still seem to think this is the baby of the Water Supply Storage Board or the baby of the Pollution Control Board. Perhaps we need to look at it from the competitions angle. Yeah, perhaps. Look, the conventional imagination, even now, with the Isharja Jaluwalia committee report, high-powered committee report on urban infrastructure, or the Planning Commission's thinking, or the thinking with the smart cities as it seems to emerge, somehow seems to be that we need 100% underground sewage, 100% wastewater treatment. That is the conventional imagination, and then there's this huge sum of some 4 lakh crores or something equivalent to that. That is not likely to act itself on the ground in the coming decades, if not years. I mean, I would think that it won't happen in the next 40, 50 years. So the reality is that we will be faced by on-plot sanitation systems and decentralized small systems. Question is, how do we encourage this? Now, the nice thing about it, it's all private money. The government is not investing in it. People are investing in it. Communities are investing in it. Entrepreneurs are investing in it. So that's good. If the government actually sees it as an opportunity where private capital can come in as a solution provider, so be it. That's the way it should be. But unfortunately, the government seems to think that it's obligated to provide underground storage systems and keeps on increasing it where there is capital subsidy, where there is O&M subsidy, and where there is tremendous inefficiencies. So somewhere the government will have to realize that it's not doing any good by intervening, that it actually does good by getting out of this space. Then once it gets out, how do they nudge better performance is a combination of many activities, which includes legal legislation, which includes information and communication, and which includes economic nudges. Combining those three and learning from rural India, especially for small and medium towns, say for example with the twin leach pit models, I think we can really go very far with urban sanitation and completely, or at least to a large extent, avoid the negative externalities. We can easily take care of environmental pollution, and we can actually bring down the negative health outcomes if we focus in the right way. See, again, in the on-site, what have we done in rural India? We've created a subsidy culture. We keep on increasing the subsidy. Till a long time, we said we're going to reduce subsidy. We said 2010, whole of India covered with toilets, and subsidy almost to zero. That was the policy thinking. Suddenly, Jairam Ramesh comes and increases subsidy. Suddenly, this new comes and says 12,000 rupees subsidy. So there also, you're distorting the market of on-site sanitation, and not necessarily in the nice way. As you're building these single pit toilets, which it is, you're still not thinking of the emptying of these. You're still not thinking of the reuse of it, even in rural sanitation. So though in rural India you imagine on-site sanitation, I don't think you do that in urban India. Where is the on-plot sanitation monies or imagination articulated in any city sanitation plan too? Let's see, this was the documents which were there. Very limited articulation of it. You see, again, it's the conventional sanitation engineer, civil engineer, and you don't blame them, but that's the kind of education they've got, that's the kind of experience they have got, and that's the kind of nudges they've been, or the signals they've been sent over 67 years. Now, when you want to step back and say on-plot sanitation, there is this resistance of its, and a lack of understanding of its performance and capabilities. But I still always wonder, why don't you see people and their initiatives as part of the solution rather than as part of the problem? There are simple things, like a pit toilet is put inside the road or the footpath. Would you or would you not allow that? It's a tough one. Because if you say that sanitation is a community activity, it has community benefits, then what's wrong in allowing it below that? Why argue that private property issue and why you do that? But you have to negotiate that and you have to do an understanding of it. It's not there in our debates now. Many a time you put in underground storage systems and you put in an initial connection cost. And you know from experience in many, many schemes that people are reluctant to pay that connection cost. Why don't you knock it off? Why don't you say zero connection cost if at all you want people to link up to sewerage lines? We still don't do that. 10% beneficiary contribution. Somehow beneficiary gets ownership if he or she pays that 10%. Why are we stuck with that 30-year-old notion that participation is financial contribution? I think some of these little points we need to sort out if we want to go ahead. This is a huge difference between a top-down planning, where you first plan the big physical infrastructure, then you reach it out slowly into lanes and lines, and then you start to figure out that people are not interested in getting connected to you. As opposed to a bottom-up planning, which we attempted in Mulbagal town, where you start the dialogue with people and ask them, how do you want your sanitation access? Do you want private toilets? Do you want functioning community toilets? How do you want to access it? And then can you build up a urban sanitation model based on what people perceive as their requirement? It's a whole different ball game altogether. And I think somewhere both of these have to talk, but it has to start with the bottom-up planning, then come down. What is the typical way we plan? Take a city town, arithmetical increase method, geometrical increase method, incremental increase method. Get the population for 30 years, multiply into 135 into 365, huge volume of water. Where do we get this water? Now, flip it around with sanitation. Okay, assume that there is 135 LPCD consumption because that's your self-cleansing velocity. Then start designing your system for that non-existent 135 LPCD. Yeah, and how do you start? With a huge volume and where my wastewater treatment plant is, and then you start to seem to come back. The last thing in your concern is how to get individual connections. Now, somewhere we have to give up that this is not working. So how do we work better? There is a serious problem with sewerage. And now you see that the manual scavenging is actually a problem not with on-plot systems but with underground sewerage systems. More people die in manholes and sewage treatment plants than they die in pit toilets and septic tanks. So your conventional imagination that sewerage will knock off manual scavenging is actually flipped the other way around. How do you deal with it? And what then is your definition of manual scavenging? Right now, the Act says that if you're in contact with any form of human waste, it's a problem. Go to any one of the sewage treatment plants. The way they're designed, the way the sludge is to be handled, the way it's to be removed, there are people handling waste. And that's the most interesting part. When is human waste, and when is it compost? When do you call it compost? Suppose I separate urine and feces, and if I handle urine, is that a problem or not? But it's not differentiated, right? It's not differentiated in the Manual Scavenging Act, it's not differentiated in agriculture. So even in agriculture, organic farming, you can't use human and animal waste. Phytosanitary protocols, EU and America, you can't use this human waste. But if it's composted for 1 year, free from pathogens, what is it that has changed that will allow its use? Because it's not a physical transformation that we are looking for. It's the social act of handling that which has been labeled under the caste system. So for us, human waste will never become compost because it's a social construct. And this is fascinating because we'll have to debate this. I mean, we'll have to figure out as a society how we deal with it. How is it to be managed then otherwise? You'll next start preventing farmers from using it under the Manual Scavenging Act. And then what do you do with these tons of wastewater and tons of sludge going out? What do you do with them? It's real problematic. You need design students, design colleges to step in and design equipment which is friendly, usable, which people will put on their own and which will make them safe. The current gumboots and gloves are completely badly designed. Nobody can. It's hot and humid out there and you're putting on this, it doesn't give you flexibility. So challenges are many in that. Even now there's no safety protocol of estimating whether there's methane in it, whether there's hydrogen sulfide in it. How do you ensure that you're safe when you go down? No, that not clear. And then there's a whole process of contracting it out. The state is abdicating its responsibility. You hand it out to some contractor, the maintenance. That fellow in turn subcontracts it. Who's then responsible for the safety of the workers when you got contracted labor? And we're seeing with solid waste that contract labor is not paid. Their regular wages, they're not paid. The system harps on efficiency, financial efficiency, and causes these problems on the ground. It's a real complex challenge. I wish we are able to demonstrate successes in 5 or 10 towns which are completely on-plot sanitation based. See, one of the things that we need to really understand is that water and wastewater and sanitation are inextricably linked. Though we say that, for a long time we focused on water. We didn't focus on sanitation. Now the pendulum seems to have swung again. Again, we seem to have gone into sanitation too much without understanding the relationship with water. The whole focus on Swachh Bharat, or the whole focus on building toilets by 2019, getting India to be open defecation free. I think we have to be realistic. Again and again, the lessons are there. If water is priced at its true ecological cost, sanitation will fall into place sooner. If water is subsidized, if there is too much of it available, it will distort the market of sanitation too. This is a very important lesson to keep in mind, and then to work with these two sectors together. But to keep this not as a single centralized space, but as a million decentralized, scaled up activities, requires competencies and skill sets which a current civil engineer or a sanitation engineer lacks. And so we have to build a design skill space, we have to build a communication skill space, we have to build a psychology, behavior change skill space, and a competitions skill space in this sector, combining water and sanitation. That is the challenge. We have to be holistic.